Assalamualaikum. My name is Muhammad Farhan bin Kamal Zaman, and I'm going to present about the introduction and the theory for this experiment. For the introduction, it seems like electroplating was invented in modern times, but actually it was dated back in 1805 by Italian inventor Luigi V. Brugnatelli. Okay, he did this by connecting wire between a dissolved gold solution and a battery known as voltaic pile. Okay, a metal object was then connected to the wire, allowing the gold to become attached to it. This had caused the metal object surface become more shiny and gold. Unfortunately, at this time, the method was not very popular, but not until in 1840s where it became popular in Russia and Britain. Okay, electroplating is also known as electrodeposition, which means that this process involves depositing material using an electric current. As a result, after electroplating process, a thin layer of metal being deposited on the surface of workpiece, called substrate. Electroplating is primarily used to alter or enhance the physical properties of an object. This, as a result, can increase the wear resistance, corrosion protection, or aesthetic appeal of the object, and as well increase its thickness. Right. So now I'm going to present regarding the theory for this experiment. Okay, electroplating is a process that uses an electric current passing in a solution called an electrolyte to dissolve metal and deposited it onto a substrate surface. This is done by dipping two terminals called electrode, which is anode and cathode, in a solution in an electrolyte solution and connecting them into circuits with a battery or power supply. Okay, anode is a positively charged electrode, meanwhile cathode is the negatively charged electrode, which is called a substrate. Okay, for the solution, the electrodeposition reaction takes place in the electrolyte solution. This solution may contain one or more metal salts to facilitate the flow of electricity. Okay, for the power source, the current is added to the circuit using power source. This power source apply current to the anode, which introduce electricity to the circuit. Okay, when the electricity flows through the circuit they make, the electrolyte split up some of the metals that are contained in the electrolyte solution and deposited it into a thin layer on top of the substrate, which is then becomes electroplated. Okay, all kinds of metal can be electroplated in this way, including gold, silver, tin, zinc, copper, and cadmium. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Muhammad Shamran, metric number 200083. Today I will be presenting the procedure of the experiment. Firstly, I will tell about the apparatus. The apparatus that we use is beaker, graphite rod, 3 AA battery, 1.5 volt each, battery holder, digital scale, bronze plate, copper nickel plate, and steel plate, and electrolyte solution, which is vinegar plus copper sulfide, and lastly is stopwatch. Okay, For the procedure, firstly, the bronze plate has been polished. Second, the electrolyte has been prepared and poured into the beaker. Third, the bronze plate was weighed using digital scale and the value was recorded. Fourth, the apparatus was set up as shown as in figure 3.1 below. Fifth, the battery was placed in the battery holder. Sixth, the positive terminal consists of graphite rod and negative terminal is consist by aluminium plate. 7. The stopwatch was started as soon as the circuit completed. 8. When the time reaches 10 minutes, the aluminium plate was removed and rinsed. 9. The bronze plate was weighed and the value was recorded in the final weight. 10. Step 3 to 9 was repeated using other BR plate but waited for 30 minutes. And lastly, step 3 to 10 was repeated by using copper, nickel plate and steel plate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rushadi bin Zanzari, DD 200089. I hope you in a good condition and have a nice day. Firstly, I would like to explain about result and calculation in electroplating experiment. Before that, I would like to show you the clip that we are doing this experiment. Let's go. So we continue for the result electroplating experiment, which is we used three type of sample. First is steel, second is copper nickel, and third is bronze. We use nil as a sample for the steel, and copper and nickel we obtain from the wire copper, and lastly is bronze, we use the coin. So after we running the experiment, we obtain the value of weight before and after. So we can look at the slide, which is the initial weight of the steel is 7.9 gram. After we running the experiment for 10 minutes, that's the final result will increase to 8.1 gram for the steel. After that, we use a copper nickel sample, which is the initial weight is 3.9 gram. After that, we regarding the final weight of the sample copper nickel, we obtain the value of weight is 4.0 gram, which is increased 0.1 gram. For the bronze, the initial weight is 5.2 gram and the final weight is 5.4 gram. That increased the 0.2 gram. That's for the 10 minutes after running the experiments. So we continue for the 30 minutes. What is happened to the final weight of the sample? Let's go. Next, we're looking for the result of the sample, which is for the steel. The initial weight that we have already know is 7.9 gram. After we running the experiment for 30 minutes, we obtain the value of final weight is 8.3 gram, which is have an increase 0.4 gram. For the copper nickel, the initial weight that we already know is 3.9 gram, which is the final weight is 4.2 gram, which is that is increased 0.3 gram. For the bronze, that the initial weight is 5.2 gram and the final weight is 5.6 gram, which is that increased 0.4 gram after running this experiment for the 30 minutes. For the calculation part, we have to obtain the rate of oxidation of the sample. For the sample still, based on the data, we calculate the rate of oxidation by the formula, which is we use a final weight minus initial weights over time in seconds. So for the sample still, 10 minutes duration, 8.1 minus 0.9 over 10 times 60 minus 0. The answer is 0.04 exponent negative 4 gram per second. So for the 30 minutes duration, which is 8.3 minus 7.9 over 30 times 60 minus 0. The answer is 2.23 exponent negative 4 gram per second. For the sample copper nickel, for the 10 minutes durations, which is 4.0 minus 3.9 over 10 times 60 minus 0. The answer is 1.67 exponent negative 4 gram per second. For the 30 minutes durations, which is 4.2 minus 3.9 over 30 times 60 minus 0 equal to 1.67 exponent negative 4, which is to have the same rate of oxidation for the duration 10 minutes and 30 minutes. For the sample bronze, which is for the duration 10 minutes, which is 5.4 minus 5.2 over 10 times 60 minus 0 equal to 3.34 exponent negative 4 gram per second. For the 30 minutes durations, for the bronze sample, 5.6 minus 5.2 over 30 times 60 minus 0 equal to 2.23 exponent negative 4 gram per second. So the factor of rate oxidation depends on the material that we use or the solution that we use when running the experiment. That will affect your result. That's all from me. Thank you.
A few reactions were observed while the experiment was conducted. Some of them were, while the experiment was ongoing, the blue color of electrolyte faded by time. It was turning from blue color initially and slowly becoming colorless towards the end of the experiment. Colorless bubble could be detected at anode of the graphite rod. Next, brown layer of solid formed at the outer part of the metal. For the first specimen, bronze, at the cathode, brown layer of solid formed. It causes the weight of plate increases after the experiment. After 10 minutes, the weight increases by 0.2 gram, and after 30 minutes, it increases into 0.4 grams. Next, for the copper nickel specimen, after 10 minutes, it gains 0.1 gram of mass, and after 30 minutes, 0.3 gram of mass. For the final specimen, still, it gains 0.2 gram after 10 minutes of experiment, and after 30 minutes of the experiment, 0.4 gram was gained.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Akmal bin Abdul Manap, and today I will present to you about part discussion and question. For first question, what material should be plating buds be consist of and why? The material that should be based on the concentration of electroplating solution. It is because to ensure the solution can conduct the electrons in it. For second question, what ions are present in the electrolyte? First, copper 2 ions, Cu2+, sulfate ion, SO4 2 negative, hydrogen ions, H+, and last one, acetate ions, CH2COO negative. For third question, give all relevant half reactions occurring at the cathode and anode. First, cuprum 2 ions will receive 2 electrons to produce cuprum. For the second one, nickel will emit nickel 2+ and 2 electrons. For the fourth question, through your observation, explain changes that occur to the electrolyte solution during the electroplating process. During electroplating process, the electrolyte solution will make a bubble at the side of the beaker. It is because of negative charge. For electroplating process of the nickel and copper plate, it will make the electrolyte slightly blue. It is because the copper 2 ions. It is from me. Thank you.
The objective of the experiment was to conduct electroplating with given metals and differentiate their coating properties. From data collected, 10 minutes and 30 minutes of electroplating resulted change in weight of specimen. We can summarize that the longer electroplating period, the heavier mass of the metal oxidized. Some of the complication in this experiment was accuracy of reading and placement of sample using alligator clips. To gain better result, this aspect need to be tackled. Thank you.